Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of integration. And if I talk about the question which is given to us here from this topic, the question tells us that if f of x is integral of 5x raised to 8 plus 7x raised to 6 upon we have been given x square plus 1 plus 2x raised to 7 the whole square dx, where we have been told x is greater than or equal to 0, and further we have been told f of 0 is equal to 0 and f of 1 is equal to 1 by k. Then we have been asked to find the value of k here. And if I talk about the options that are given to us here for the value of k, it is given to us as 1, 4, 9 and 16. So let's figure out which of them can be the value of k here. So let's first figure out the value of this integration. So f of x, if I see integral of 5x raised to 8 plus 7x raised to 6 divided by x square plus 1 plus 2x raised to 7 the whole square dx. So if I try to take out the powers of x common here, let's see from the denominator if I take out common, the maximum power I can have here is x raised to 7 the whole square, so x raised to 14. If I take out common here, let's see what I get. So if I try to analyze it, I am dividing throughout by x raised to 14. So basically, if you understand, I'm dividing in the square by x raised to 7. So if I write x raised to 14, I can also write that as and multiplying by x raised to 14. So the divided term, I can write that as instead of x raised to 14, I can write that as x raised to 7 the whole square. So what you get is in the denominator, you have x raised to 14 already. Here you have dx. Here your denominator becomes square x square plus 1 plus 2x raised to 7 upon x raised to 7. So you get this entire thing. Integral 5 x raised to 8 upon x raised to 14 plus 7 x raised to 6 upon x raised to 14 dx, the whole thing upon. Here if you see in the square, you have x square upon x raised to 7, that is 1 upon x raised to 5 plus 1 upon x raised to 7 plus 2x raised to 7 upon x raised to 7, that is 2. So you have this entire thing here. If I try to simplify this idea, f of x becomes integral of 5 upon x raised to 6 plus 7 upon x raised to 8 dx, the whole thing upon in the square you have 1 by x raised to 5 plus 1 by x raised to 7 plus 2. Now what I understand from here is, since this becomes x raised to minus 5, if I take the derivative, I'll get that in terms of minus 6. So this gets adjusted. Also, this x raised to minus 7, if I take the derivative, I'll get x raised to minus 8. So this also gets adjusted. So what I understand from this hint here is that if I put 2 plus 1 upon x raised to 5 plus 1 upon x raised to 7, the whole thing in the denominator as t. So if I'm substituting this as t, and if I take the derivative of that, it becomes derivative of 2 is 0, derivative of x raised to minus 5, that becomes minus 5 x raised to minus 6, and this becomes x raised to minus 7, so minus 7 x raised to minus 8. The whole thing with dx, it's equal to dt. So if I try to simplify this further, I get minus common 5 upon x raised to 6 plus 7 upon x raised to 8 dx is equal to dt. So your f of x, the function which is there, you get this entire numerator adjusted as minus dt. I'm just taking that minus sign on the other side. So you get that as minus dt. So your integral f of x becomes minus dt upon t square. So when you have minus dt upon t square minus 1 integral of dt upon t square, I can write that as minus 1 integral of 1 upon t square. I can write that as t raised to minus 2 dt. So that makes it minus 1. This becomes t raised to minus 1 upon 1 plus c. So t raised to minus 1 upon minus 1 there. Because x raised to n plus 1 upon n plus 1. So you get minus 1. Minus and minus gets cancelled with each other and you're left with basically t raised to minus 1 plus c is your answer for x. So you get that as f of x becomes 1 upon t plus c. But since I need my function in terms of x, I'll resubstitute t. So what I substituted t as? I substituted t as this entire thing. So I'll resubstitute. I get 1 upon x raised to 5 plus 1 upon x raised to 7 plus 2 plus c. So you get this entire thing. If I again multiply and use the idea, I can write that as x raised to 5. So if I multiply with the LCM, that is x raised to 7 on both sides. So multiplying the numerator and denominator by x raised to 7. So your terms become, instead of 1 in the numerator, you will now have x raised to 7. Denominator, you will get it x raised to 7 upon x raised to 5, that is x squared, plus x raised to 7 plus x upon x raised to 7, that is 1. And you have 2x raised to 7 plus c. That's your value of f of x. Now to find the value of this constant of integration c, we'll use the condition given to us, that is f of 0 is equal to 0. So if I put that, I know x is 0 and for that the function's value equals to 0. So f of x I'm putting 0. It is equal to 0 upon 0 plus 1 plus 0 plus c. So this is also 0, this is also 0. So constant of integration also 0. So you get your f of x as, let's see what I get, x raised to 7 upon x square plus 1 plus 2 x raised to 7. So you get this entire thing. Now if I just want to find, I have been told that f of 1 is 1 upon k. So let's put x as 1 and let's find what is f of 1. So if I put x as 1, f of 1 becomes 1 raised to 7, that is 1, upon 1 square, that is 1, plus 1, plus 2 into 1 raised to 7, that is 2. So you get f of 1 as 1 by 4. And you were given f of 1 as 1 by k. So if I see here 1 by k is equal to 1 by 4. If I solve that further, I get the value of k as 4. So I get the answer for the value of k, and if you see the option that matches here with the question, that is option B. So B is the correct answer for the question given to us. I hope you have understood how to solve this type of questions, which deals with the ideas of finding the values of the unknowns here as we did in this question. So we first figured out how to solve this integral. We divided by x raised to 14 and multiplied by x raised to 14 in the denominator. Then whatever we got in the numerator, we substituted the entire term as t. So the derivative of that got adjusted in the numerator terms. Once that got adjusted, you just solve the integral and got the answer in terms of c. Putting f of 0 equal to 0, you got the value of c. And then you put x as 1 to get f of 1. Equated that with 1 by k, you got the value of k as 4, and that matches with option B. So B becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions which deals with the ideas of integrals. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on 11, 12 as well as JEE mains. So stay tuned for more videos to roll out. Also, do like, share, and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of the questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.